So, hi everyone, Senan this side, and today we are going to solve this LeetCode daily problem number 214, which is the shortest palindrome. And it's been a long time since we have seen a hard problem on LeetCode daily. So the question is, you're given a string S and you can convert S to a palindrome by adding characters in front of it. Okay, return the shortest palindrome you can find by performing this transformation. So why shortest? Because you can make as long of a palindrome as you want. You just take this word, flip this, add it into the front, and add infinite number of characters in between of, like, that should be a palindrome itself. Like, you can actually add infinite number of a's in between and still you will find a palindrome. Obviously, to check this you should have a finite length. So if you give me a palindrome of size 13, I can make that palindrome of a size 113 as well by adding 100 a's in between. So the idea is we have to return the shortest palindrome. Okay, so what could we do? So let us look at this test case first, which is A, CEC, AAA, right? And if you see, this is already a palindrome, right? AACE, CAA, and A. So what you could do, just take this single A and append it into the front of the string. So you have the shortest palindrome. What would you do if the string is itself a palindrome? You return that string itself, right? That would actually be the shortest palindrome then that you can actually make. Now what about this ABCD? Now if you look this from the starting point, A is itself a palindrome, right? A single character is a palindrome. So what I do is I take the remaining string, which is BCD, reverse it to make DCB and append it into the front. So DCBA, BCD. So we now get the idea what we are actually going to do, right? And now let's jump onto our notebook and see how this is actually done. So let's say you are given this example and what you have to do is find the shortest palindrome, right? By adding elements to the front only. So the idea would be to, okay, not just idea, let's say CE, DAAD, DAA, DEC. So what I could do is actually, if I reverse this, right? If I reverse this and add it, this is definitely what could be our solution if there are no palindromes inside this, but this has one. So this could be our possible answer. This cannot be our possible answer as well. So if you observe, if I remove one of the D's, right, this would still be a palindrome. So now given this string, is this the shortest one? And technically I would say no, because if I just, for example, remove this D double A, so in the end what we would get is something like this. Fine. So if I just remove this part, what I'm remaining is with this one and this part, the CE. Now if you observe, this is actually a palindrome, right? C matches with C, E matches with E, D matches with D, A matches with A. This is a palindrome. Obviously we have the word itself, like this one. This word exists here. So there are only two characters that we added into front of this string to get a valid solution. And if you observe, this is the shortest one that is. So the idea, as in the test cases as well, is to find a substring which is a palindrome starting from the first, right, which is this, and you take the remaining portion of the string, you reverse it and append it in the front of this string, and that would be your solution. So this means our question now boils down to the part to finding a palindromic substring starting from index 0. Okay, so this is your problem now. So we have modified this problem, and once you see this, you would realize this is a classic algorithm, which is the KMP algorithm, and that would actually help you to find this. Now how would we actually use KMP algorithm? So so this is actually a name of someone, so I will just use that KMP algorithm as a black box, but I'll just do the explanation because I will be making a full video on KMP itself. That is why I don't want to go over each and every detail of the KMP, but I will basically discuss the overview of what the KMP algorithm will actually do. So given this example itself, I'll use this my example, so which is DAADENC, right? And now what I would do is I would actually reverse the string and append it to the original string. Now one more thing, what you would require is a delimiter in between, or a separator, not a delimiter but a separator in between, to just separate these two parts. Now given in the question that the words would has only lowercase character, so any character other than the lowercase character can be used as a separator. Now we will discuss why we need a separator, but before that let's discuss the idea first, why we are doing what we are doing. So there's a notion known as the LPS, which is longest prefix which is also a suffix. So let me just write this. So longest prefix which is also a suffix. So what is the role of KMP algorithm? So the role of KMP algorithm is to basically given a string and given a pattern. So let's say this pattern exists in this part of the string. Let's say write this like this. So given this string and let's say this pattern is exactly same as this, the KMP algorithm, what it would do is basically find this, right? The idea is to find a pattern that matches this in this bigger string, right? So the idea of KMP is this, but what it does is finds the longest prefix which is also a sub, right? So this allows us to do the traversal only once in this string that we have to find this pattern. So what it allows us to do it in linear time. Otherwise what you would have done is take this string, start searching from here, and you did not see, then you move one step ahead, then you do a search again, then you move one step ahead, then you do the search, you move one step ahead, do the search, and so on. So in that case, in the brute force case, the complexity would be m times n, where the size of this n, the size of this m, and in the worst case you would have to do m times n operations just to find that. But if you compromise on space, right, compromise on space, what you could do is you could achieve this with O m plus n, and that is the idea of KMP, right? So you improve your time complexity from m times n to m plus n. So that is the idea of KMP. So what it does is, let's take an example, say a b c d e a b c. Let's say you have this string. So you see this starts with ABC, this ends with ABC, right? So longest prefix which is also a suffix. So this part is prefix, this part is suffix. So we have occurrence of prefix and the same thing as a suffix, right? So now this gives you the idea of how do you actually solve this problem. Now given this list, right, I'll just copy this. So now if I use the KMP algorithm on this string, now what I would find is the longest prefix which is also a suffix is this part, DAAD. And since this prefix is same as this suffix, but we know this string is through construction, this part and this part would be reverse of each other as well. So prefix is equal to suffix, right? It is also equal to reverse of this suffix. So that means these two are palindromes, right? Prefix is equal to suffix as well as it is reverse of suffix, right? This is equal to this, so this is equal to this itself, but this is also equal to the reverse of this. So that means we found a palindrome starting from the 0th index. That is the idea. So we found a palindrome. So that is the idea of KMP algorithm. And now in the end, what would KMP return is the length of this, because we know it is always starting from this 0th index, right? So what in the end what I would do is return this length through this KMP algorithm. Now you could actually do this using the brute force of which I discussed. We go of m times n, and that actually works, but KMP allows you to do this in linear time. So that is the idea of KMP. Now the next thing is, why are we using this separator? Now to understand the idea of the separator, let's look at this test case. Let's choose any character. A is to classic. Let's choose S, first character of my name, and let's say the word is 4 times S. And what I do is I now reverse this S, S, and S. What do I have? 4 times S and 4 times S. Now if you note, I try to write this in the reverse format. Just look to make it look like we are actually reversing this. So now what is the longest prefix which is also a suffix? And if you clearly observe, in this case longest prefix which is actually a suffix is this whole string, which is actually twice the length of the string itself, and which we don't want. We want to find a prefix which has a length less than the length of the string itself, right? So this is what we did ourselves. So since we know this hash is not in our is not a member of any word that we are going to into this function, we know the hash won't exist anywhere. So what I do is add an hash in between. So what it will do is it can only check the prefix till here, and whenever you see a hash, no suffix would have an hash after this, right? So at max what you could find is a prefix of length 4 in this case, right? That's the best you can actually do. So hence we use a separator so that we don't get a suffix of a prefix which is actually greater than the length of the string itself. Now we are done, almost done. Now we started with this example DADEC, and I do the KMP algorithm, sorry, the wrong pen, and this gives me answer as 4, as the 4 is the first string, which the length of the string is 4, which is also a palindrome starting from index 0. Okay, we're done with this. So this let me write this properly. This on input to the KMP would give me the value of 4. Now what I'll do is I'll keep the string as it is, right? So let's call this string as s. I'll keep this s as it is, and I'll try to concatenate with what is the length of the string here, which is 6. So what I'll do is take what do I take? So 6 minus 4 is equal to 6 minus 4 is equal to 2. And what I'll do is I'll do reverse of s and then take the first two elements of this. So when I reverse this, I get, so reverse would give me CED, AAD, and if I take this, do this operation, and I would get the first two elements of this, which is CE, and then I'll add this to S, and this would actually be my answer. So I would get C times CE and then DAADEC, and this is your final answer. That is what we are going to do. Now let us actually look at the code of how we are actually going to implement this. Fine. So now we are in my what do we call this, IDE. So okay, let's do this. So first what I do is I create a string which is the reverse of s, and I just pass this s.rbegin to s.rend. So this is basically the iterators that would traverse the string from right to the left. And what this does is nothing, it just shows the reverse. So now what I do is take the max pal length, which is maximum palindromic length from the starting, and I call this KMP on s, and I pass reverse of s as well. You could just pass s and just reverse it in the KMP algorithm, but let's do it this way. It's more clear. Now what I do is I take the reverse the string, I take the substring and 0 to s dot size minus max palindromic length. So that is what we did. 6 minus 4, you remember 6 minus 4 that we did in the notebook. This is that part, and we are just taking the first two, or the first s dot size minus max pal length of the substring, and I'll just append that to the given string, and that is what I would be going to return. Now private, so this takes two strings by reference. Actually you could add a const in front of this as well, because you're not actually manipulating the string, but anyways. Now I create a combined string which is s1 plus the separator and s2. S2 is what is actually the reverse, right? So technically I could actually have reversed inside this KMP function. That would be more simpler, but yeah, that's the thing. S1 delimiter, and then now what I do is I create a vector of LPS of this size of this string. LPS is what? Longest prefix, which is also a suffix, right? Now this is the classic way of doing the KMP. You have two iterators. You traverse using J, you will traverse the whole string once, and depending on the position of I, you can actually do the pattern matching, and in the end whatever is the last element in this list would be the number of elements in the palindromic string, and that is what we do. And I've already explained you how this. So let's discuss the time and space complexity. Okay, so LPS is big O of 2n plus 1, where n is the size of put s, so n plus 1 plus n, which is 2n plus 1. So the size is big O of n. Also we're traversing this whole string once, right? So that would give me big O of n, and I is also right. So we are traversing from j and as well as I as well, from j 0 from 1 to n, and I is 0 to n as well. So big O of 2n maybe. So that would give me big O of n time, big O of n space using this KMP, and getting the reverse is big O of n, getting the substring is big O of n. So that actually give me big O of n time, big O of n space, and that is the actual solution. This is accepted and it actually beats 100%. So yep, I started by, yeah, that's it. If you see, this is quite straightforward, and I hope I was able to explain this to you. Definitely, I would have a separate KMP algorithm video coming soon, so stay tuned, and I'll see you in the next video.